There are certain conditions that exact solutions of variables are not identified due to the multiplicity of equations provided. Learn about it here in Numerical Solutions to See Problems. Gaussian elimination is one approach in solving systems of linear equations. This method uses half of the solution by creating a triangular matrix, then computing for the values by algebra. In transforming a matrix, extract the coefficient of each term and arrange them in an augmented matrix. What do we mean by Gaussian elimination without pivoting? Pivoting is the manipulation of the equations or rows and given columns to rearrange the terms in a matrix. The approach using row operations exclusively is termed as partial pivoting, and the other approach, which moves rows and columns, is complete pivoting. For Gaussian elimination without pivoting, the distinguishing marks are first, the rows are never interchanged. Row operations are generated using the original location of the equations or rows. The third example contains 5 equations involving 5 variables, and we are to solve them using Gaussian elimination without pivoting. The initial step is to generate an augmented matrix. Using the standard procedure, use the first row as pivot row and zero out the other elements under the first column. These are 4, 6, 8, and 10. The row operation to zero out 4 from the second row is R2 less twice of R1. The first element takes 4 minus twice of 2, giving 0. The second element is 6 less twice of 4, resulting to negative 2. The next is 8 minus 2 times 6, which is then negative 4. Followed by 10 minus twice of 8, which is negative 6. The fifth element is 12 minus 2 times 10, giving negative 8. From the constant, there is 172 minus twice of 130, which results to negative 88. The next element to zero out is 6 from the third row. The operation is R3 minus thrice of R1. The equation then transforms the first element as 6 minus 3 times 2, giving 0. The second element has 8 minus 3 times of 4, which gives negative 4. The following element is 10 less thrice of 6, resulting to negative 8. The fourth element then has 12 minus thrice of 8, giving negative 12. The last element is then 14 less thrice of 10, which becomes negative 16. Under the constant column, there is 214 less thrice of 130, which gives negative 176. Zero out 8 from the fourth row of the first column. The row operation to use is R4 less 4 times of R1. The first element is 8 less 4 times of 2, which is 0. This is followed by 10 minus 4 of 4, giving negative 6. The next element is 12 less 4 by 6, resulting to negative 12. The fourth element has 14 minus 4 times of 8, which gives negative 18. And then 16 minus 4 of 10, which yields negative 24. For the constant, there is 256 minus 4 times of 130, which is negative 264. Zero out the last element in column 1 using the operation of row 5 less 5 times row 1. This starts with 10 minus 5 times of 2, which is 0. The second element is 12 less 5 times of 4, giving negative 8. The next element is 14 less 5 of 6, resulting to negative 16, followed by 16 minus 5 times 8, and that is negative 24. The last element has 18 less 5 times 10, resulting to negative 32. From the constant column, 298 minus 5 times 130 is negative 352. After finishing the first column, we then use the second row as pivot row to zero out the other succeeding elements under the second column. To work on the third row, the operation is R3 minus twice of R2. From the first element, 0 minus twice of 0 is 0. This is followed by negative 4 minus 2 times negative 2, which is also 0. The third element is solved from negative 8 less twice of negative 4, which is simplified as 0. Then negative 12 minus twice of negative 6 is 0. For the fifth element, negative 16 less twice of negative 8 is 0. The last element is negative 176 minus twice of negative 88, which is also 0. For the fourth row, use the operation R4 less thrice of R2, thereby simplifying the first element from 0 less 3 times 0, which is 0. This is followed by negative 6 minus 3 times negative 2, again 0. The next element is negative 12 minus 3 times negative 4, also 0. Element 4 has negative 18 minus thrice of negative 6, which is 0. Followed by negative 24 minus 3 times of negative 8 as equal to 0. From the constant, negative 264 minus 3 times negative 88 is again 0. So far, the two rows contain 0 values, so let's check the last row. Use the operation R5 minus 4 times of R2. The elements start with 0 minus 4 of 0, which is 0, followed by negative 8 minus 4 of negative 2, also 0. The third element is negative 16 minus 4 of negative 4, giving 0. And the fourth element is negative 24 less 4 times of negative 6, also 0. For the fifth element, negative 32 minus 4 of negative 8 as 0. The constant also shows 0 from negative 352 minus 4 of negative 88. With all other rows showing 0, we can only work with the first and second. Simplify each of them by dividing the first row by 2, where elements turn into 1, 2, 3, 4, 5, and 65. The second row is also divided by negative 2, giving elements 0, 1, 2, 3, 4, and 44. Simplify the two equations further by subtracting R2 from row 1. The first element then is 1 minus 0, which is 1. Element 2 is 2 minus 1, as 1. Element 3 is 3 minus 2, also 1. Element 4 has 4 less 3, giving 1. Element 5 is 5 minus 4, also 1. Then from the constant, 65 less 44 is 21. This is the most simplified state where each column is designated as X, Y, Z, W, and V. The equations can then be written from the first row as X plus Y plus Z plus W plus V as 21. Then from the second row, the equation is Y plus 2Z plus 3W plus 4V as equal to 44.